Software engineers face a trade-off between quality and velocity. You can choose a frontier model that drains your budget and slows down workflows, or a faster, cheaper model that lacks the logic to handle complex codebases. For high-stakes coding, GPT 5.5 and Opus 4.7 are currently the industry standards. However, their premium API costs and high latency can create bottlenecks during intensive development sessions. Cursor Composer 2.5 enters the market with a specific goal, providing that same frontier-level intelligence while increasing efficiency tenfold. This graph tracks performance on core engineering benchmarks. On the capability axis, Composer 2.5 clusters with Opus 4.7 and GPT 5.5. But horizontally, legacy models shift toward high cost and high delay, while Composer 2.5 remains locked in the highly efficient lower left corner. Composer 2.5 targets the specific friction points of speed and cost that usually stall a daily development cycle. Shifting the cost-to-performance ratio allows engineers to rethink their workflow, treating high-tier intelligence as a standard daily resource rather than a limited one. This performance profile starts with the model's foundation. Composer 2.5 is built upon the open-weight Kimmy K2.5 base model. To refine that base, the Cursor team partnered with SpaceX AI, utilizing the Colossus 2 data center to conduct intensive reinforcement learning focused strictly on coding logic. This training resulted in a 200,000 token context window, giving the model the capacity to hold entire application architectures in its active memory. There is a trade-off for this efficiency. By optimizing so heavily for code, Composer 2.5 lacks the creative writing flexibility or general trivia knowledge found in more generalized models like Claude or ChatGPT. For software engineering, that specialization is an advantage. The model trades general-purpose conversation for mastery over a codebase. The pricing for Composer 2.5 is set at 50 cents per million input tokens and $2.50 per million output tokens. This chart shows the average cost per task. At these rates, Composer 2.5 operates at roughly 1/10 the cost of the frontier models from OpenAI and Anthropic. For solo developers, this price point enables continuous agentic loops and high-volume testing without the risk of a prohibitive API bill. Users also have the option to toggle on a fast variant model within the Cursor interface. The fast variant maintains the same level of intelligence but prioritizes execution speed and a lower time to first token for developers who need instant feedback. That speed comes with a financial cost. The fast variant is roughly 6 to 7 times more expensive than the standard version, reducing the primary budget advantage of the model. By placing this toggle in the UI, Cursor allows developers to decide when a project requires immediate velocity and when it's better to prioritize cost efficiency. We tested the model's raw capability with a zero-shot prompt, asking it to build a browser-based operating system from scratch without a predefined plan. The model produced a functional HTML environment with a system clock and functional minigames in a single generation. In a separate test for a beat-em-up game, it successfully implemented complex physics, player collisions, and movement mechanics on the first try. Beyond text generation, we also tested how the model uses vision to debug broken applications. We provided the model with this screenshot of a 3D driving game, where the isometric map was rendering incorrectly and overlapping other elements. Using only that visual evidence, the model identified the rendering bug and provided the fix without requiring any text-based explanation of the problem. However, these UI tests also highlighted a limitation in the model's design sensibility. While the structural logic is reliable, the visual aesthetic of the front ends it generates is often rigid compared to the more creative design outputs seen in Opus 4.7. Composer handles the core system logic effectively, but design-heavy tasks still benefit from the nuanced creative sensibilities found in specialized models. Our final test asked the agent to go beyond the IDE and interact directly with the operating system to install the Godot 4 game engine from a local zip file. The agent autonomously unzipped, installed, and configured the engine on an Ubuntu system, removing the need for manual terminal commands. Granting an AI these types of permissions requires careful local sandboxing to ensure your system remains secure. These capabilities are most effective because of how they are integrated into the Cursor IDE. Features like the native plan view, inline architecture diagrams, and a customizable right-hand panel are designed to reduce context switching. Pulling terminal outputs, file editing, and PR reviews into a single interface eliminates the need to switch between the editor and separate browser-based AI apps. Composer 2.5 functions as the central engine within this closed-loop ecosystem, keeping your hands on the keyboard and your focus on the code. To get the most value out of these tools, you have to know which model to assign to each stage of your development cycle. This matrix provides a framework for selecting the right model. Legacy models remain the best choice for edge cases. Use Opus 4.7 for front-end design and GPT 5.5 for back-end architecture. But for daily scaffolding, iteration, and debugging, Composer 2.5 is the most efficient choice. Use Opus for aesthetic vibe coding and GPT for high-level architecture, but make Composer 2.5 your default setting for active development. By turning frontier-level intelligence into a low-cost, high-speed baseline, Composer 2.5 removes the financial barriers that previously gated modern software engineering.